following video is a real electrical troubleshooting example using Business Industrial Network's award-winning Advanced Electrical Troubleshooting Training Simulation software.
This video demonstrates how to locate and repair a motor circuit fault. Effective troubleshooting starts with preparation. It is important to have all the diagrams and documentation for the system, as well as an understanding of how it is designed to operate. After reviewing the problem description, we're ready to begin. We start by observing the state of the system in its as-found condition. The sight gauge tells us that the tank is full and that the mixture appears about right. The status of the previous batch was timed out, which means that the last batch did not reach its destination. All the lights on the control panel are off and the emergency stop button is pressed. The next step is to operate the system and look for signs of abnormal behavior. Before we can start the cycle, we must first release the emergency stop and drain the tank. The power and drain lights on the control panel turn on and the tank drains normally. Once the tank is empty, the ready light comes on. When we restart the system, the cycle and intake 1 lights turn on and the tank begins to fill with the first fluid. At the midway point, intake 1 stops and intake 2 starts. Once the tank is full, the second intake stops. At this point, the agitator light should turn on, but it does not, and we do not hear the agitator start. Inside the power box, we see that the agitator's overload is tripped. Resetting the overload causes the agitator contactor to pick up, but the overload trips again after a few seconds. To sum up our observations, we saw that the cycle operates normally up until the point when the agitator should operate, at which time its overload trips. The observations tell us a lot about the problem area. The control portion of the circuit can be excluded because it works as expected. In the power circuit, we can exclude the 2 phases which supply the control circuit. Also, since the overload trips, we know that there is current in at least 1 phase of the agitator circuit. Therefore, the problem area is confined to the agitator power circuit and the 3rd supply phase. We now need to consider the possible causes. Any one of this list could produce the symptoms we are seeing. Now we consider if there is an obvious probable cause. Several are more likely, such as an open fuse or problems with the motor, but there is not one that stands out. Based on this, we need to reduce the problem area by testing. Because the overload trips, we know that there is excessive current in 1 or more phases. Therefore, our first test is to use the ammeter to measure the current in each phase. We read locked rotor current in 2 phases, but no current in the center phase. Therefore, there is an open in the center phase. In the new problem area, the fuse is now the best place to test, as a blown fuse is an obvious probable cause. To safely test voltage in the power circuit, we open the breaker each time we place the leads. The readings all show full voltage, indicating the fuses are okay. We now know that the fault is an open in the center phase, somewhere between the bottom of the fuse and the motor start point. Since there is no obvious probable cause in the new problem area, we will need to perform tests to reduce it. To find an open in a 3-phase motor circuit, an ohm meter is the best choice. So we need to lock out the circuit. Next, we sectionalize the circuit where it leaves the power box by disconnecting a wire and measuring from there to the fuse with the contactor closed. We read infinite resistance. This means that the open is within the control box. We split this area in two at the bottom of the contactor. The low resistance reading tells us the open is above the test point. Testing at the top of the contactor with it closed indicates the contact is okay. Now, the only possible causes are one wire and its connections. We begin to disconnect the wire, but find a loose terminal. Since this fits the symptoms, we tighten the terminal to repair the circuit. To verify the repairs, we test the full path through the motor. The low resistance reading indicates the path is complete. Next, we get ready to operate the system to make sure there are no other problems. Restarting the system, we see the tank begin to fill with the first fluid, and then switch to the second fluid. Once the tank is full, we hear the agitator start, indicating that we have repaired the malfunction. The cycle now continues, mixing and heating the fluid. When the proper temperature is reached, the agitator and heater stop, and the mixture is pumped to its destination. The batch status now shows passed, so we are done. The work order shows the total time and cost for the repairs. An evaluation of our troubleshooting process is also shown. We can use this information to improve our techniques in the future. You can learn and practice your skills on more than 50 faults like the one shown in this video.